Hi, in today's session we're going to look at regression analysis. Specifically, the webcast will allow you to be able to do the following. Run a multiple regression with several indicators. We're going to keep these indicators consistent in this example, and therefore they'll be on the same scale. Before we go on to that, just a recap of what regression actually is. What regression does is allow the prediction of a continuous dependent variable as a result of one or more independent variables. When we have one independent variable, we call this simple linear regression. But in this example, because we're going to use more than one independent variable, it's called multiple linear regression. Essentially, as a result of our model, we're able to estimate our R squared, which suggests the amount of variance that's explained by our independent variables in our dependent variable. But before we can do any regression analysis, it's really important that we have validated our assumptions. And there are several that we have with multiple regression. These are actually covered in an earlier tutorial, so I would advise people to go back to those before you continue with regression. The example we're going to run today comes from the OCGS dataset. We want to establish whether product quality, complaints handling performance, friendly staff has an effect on satisfaction, and to what extent that is the case. Essentially, we want to identify whether quality has a larger influence on satisfaction than complaints and friendly staff, or vice versa, one of the other variables has the largest influence. More importantly than that, we want to establish whether those three variables are in fact drivers of satisfaction. Why is that important? Because for a grocery store, making changes or implementing new policies around any of these three variables, if they're not going to increase satisfaction, might be a waste of time and money. Similarly, at the same time, if we have only a limited budget, we probably want to identify which of these variables is most likely to have an effect on our satisfaction or customer satisfaction and implement these first. Okay, so we're in our SPSS data set. We want to see whether satisfaction is driven by product quality, complaints handling, and friendly staff. The way we do this in SPSS is to use our analyze pane, analyze, regression. In this particular example, we have a continuous dependent variable, and therefore we're interested in linear modelling. Click on linear. Move our satisfaction variable, question 7, into our dependent pane. Move our independent variables, which is product quality, complaints handling, and friendly employees, and we move that into our independent variables. Let's have a look at the statistics that we're allowed. We're not actually changing our R squared, so we haven't got more than one model, but what we will do is take descriptives, part and partial correlations, and collinearity diagnostics. We've had a look already at our assumptions, and therefore we are less interested in our residuals. It's a similar story with our plots. We've already covered these in an earlier tutorial. And here we have everything that we need clicked. So essentially it's a case of clicking OK and running the analysis. We're thrown up a few different statistics. Firstly, we've got the descriptive statistics we've asked for each of our variables. You can see here that friendly employees' performance is actually higher than any of the other variables that are independent, and indeed the dependent variable. We've also asked for correlations. Now this is really important because it shows us how our independent variables interact with each other. The first box actually gives us our Pearson's correlation, and the second box gives us the significance test. course, it's a one-tailed test as opposed to a two-tailed test. The third box gives us the number of cases that we actually have in our data set, which is 206. We can see here that there is actually a reasonable correlation between product quality and customer satisfaction. Although we have to actually go ahead and run this analysis, we'd say for our dependent variable, for each of the independent variables, actually from the off it looks as if product quality might have the largest association. We can then move down our data. I just want to highlight this one here. This is our model summary, very important table. What it essentially shows us is that we have 0.418 rounded to 0.42, which is 42% of variance explained in our dependent variable as a result of our 3 independent variables. So essentially, 42% of variance in satisfaction is explained by product quality, complaints handling, and friendly employees. What does that also mean? It means that 58% of variance is explained by other items, and that we might have to adapt our model to try and increase the amount of R-squared we have. This table here, ANOVA, what we're really interested in here is the F statistic and its corresponding significance value. What we can determine from this, because P is less than 0.05, is that our model is a better fit to the data than just taking mean scores. Therefore, we should keep our model as opposed to having no model. Okay, and we've kind of validated that through that particular statistic, so we know that what we're doing is appropriate. Now, the key to interpreting our data is in this particular table here, our coefficients table. Now, what we're interested in is the unstandardized coefficients for each of our variables. We can put this into our equation, y equals a plus bx, 1 and on and continue to bx2, bx3. But on the offset, I can see that we've got some insignificant variables, one being the constant and the second one being our complaints handling performance. What can we determine from that as opposed to product quality and friendly employees? Well, we can suggest it suggests here that actually as a determinant of satisfaction, only product quality and friendly employees are influential in driving variation in satisfaction. We can set this up as an equation, as I suggested, whereby y equals minus 0.66 plus bx, which is obviously 0.560, plus 0.396 friendly employees. Initially, we can see here that actually, as we would expect, product quality has the largest effect on customer satisfaction. We can say from there that a 1-point increase in product quality performance, remember it was measured on a scale of 1 to 7, so say we move someone on a scale from a 4 to a 5 by making some change to the quality of our products, we will improve satisfaction by 0.56 points on a scale of 1 to 7. Okay? Interpreting friendly employees' performance, exactly the same. A 1-point increase in how friendly our staff are to customers will result in a just less than 0.4 point increase in satisfaction.